one of the 3D things I want to look at is a hologram. I'm going to hand this round and you can all have a go with it. We've all seen holograms on our credit cards with the fluttering wings of the little bird. This is a big one. It's got a big owl in the middle of it, the head of an owl. And either side of the owl, on one side it's got a picture of some land-based eagle, and on the other side it's got some picture of a fish-eating eagle, okay? Now there's instructions on the back as to how to get the best out of it. Feel free to take it outside afterwards, because the more light there is, the better it works. But these three creatures are totally 3D when you get a lot of light around them, okay? Now the amazing thing about the hologram is that if you break it, there are still in all of the pieces, those three images in their entirety. So you would still see the full owl and the two eagles, and they would still be 3D, but the colour and the depth of the image would be less the smaller the pieces are, which is why we need billions of us to generate this amazing hologram that we're working on. Fantastic technology, this. The mathematics was developed in the 17th century by an alchemist called Leibniz. We had to wait 250 years before we had coherent light in the form of lasers to make things like holograms. Now, if you get the light exactly right on this hologram, what you'll see is just a meaningless bunch of squiggles, which is what is actually on the photographic plate. Okay? So your consciousness is cooperating with technology to tug the third dimension out of this flat piece of glass. I'm going to hand it round so that people can have a look at it.
So if it broke into 1,000 pieces, each piece
all of the three images. The idea, of course, being that the same is true of us. We are holographic systems. Every single bit of our DNA contains enough information to rebuild the entire system. And that is true of every other bit of the system as well. That's really a subject for the next geometry talk, though, that one. So that's a hologram. Even more amazing, I said that there's squiggly patterns on the bottom of the hologram when you can penetrate it. Here's some squiggly patterns on a postcard. I've had this postcard for ages. It took me 5 years to make it work. Has anybody ever come across these 3D images?
Yeah. I've seen one of them, and if you hold it close to your nose and pull it away, you can see a dinosaur.
Thank you very much for the explanation of how to do it. You relax your eyes, you get it close to your eyes, you move it away. This particular one's not a dinosaur. What it's got is these fantastic psychedelic multicoloured swirly columns that leap from the card in 3D such that you can almost look between them. And as you look between them, the card's surface looks spherical. No longer flat, okay, spherical. Absolutely fantastic, and that is your brain pulling 3D out of this. So it's got to make you start wondering about how much of 3D is exactly what it appears to be. I'll hand that around. Most people can do that. I'll warn you that if you succeed, as you come back to the tent, you are likely to feel a little bit queasy. Anybody who wants to go, there's two books of 3D pictures here. There's several that look like this. You can't see what's going to come out of them, and they're harder to do than these ones where you can see what the 3D image is going to be. You just pull in the 3D out of it. Okay, so I'll hand those. Does people want to have a go whilst we're playing? Okay. Can you pass that back to the enthusiast at the back? There are some people, especially we've noticed people like policemen and stuff, can have a bit of a difficulty adjusting their perception to see this sort of stuff. But the cheer that goes up when they pull it off is amazing. Anybody who can't do it, I've got my little 3D body book here, which has got loads of really enticing pictures of the inside of human heads and stuff like that. But it's also got some yellow and red glasses, so that'll pull the 3D out of the images for you if you can't do it with your head. Just exactly why green and red should make us see 3D in something that's flat is, of course, completely another question. So there we are in the 3D. That's just a quick idea of how complicated it is. We'd also normally look at a slide which shows an old lady. It shows an old hag, but also a very young lady, depending on how you see it. Has everybody seen pictures like that? Well, you actually can't see both of those things at the same time. They're actually emerging into consciousness and submerging themselves back into the cosmic background all the time. And they do that roughly 6 times a second in your normal human being. So we're effectively seeing the world in 6-second slices. So not only is the third dimension a bit iffy, but the whole thing is actually more like a freeze frame. And loads and loads and loads of incoming data is actually being suppressed by our consciousness to stop us getting too confused. So what is it that's conscious underneath that suppression, I wonder? But so that's a little bit of excitement, really. We're going to move towards the actual geometry. This sphere looks absolutely fantastic sitting there in this dome with the reflection of the dome on it. It's where we're going to start. We start geometry with a sphere because it's the shape that we're most familiar with. We live on a sphere. Everything we look out at in space turns out to be a sphere if it's above a given size. We look out at the world through spheres. The first cell is a sphere. All of our cells are spherical when they start, before they divide themselves. And the first cell, the egg, which is made up of the male and the female parts, is the largest cell that there is in the human body before it starts dividing, and it too is a sphere. For that reason, the ancients were fascinated by spheres, and spheres turn up a lot in alchemy, and the music of the spheres, we'll all have come across it in our research, I'm absolutely sure. But as it turns out, there's sphere upon sphere upon sphere. We live on planet Earth. Outside planet Earth, there's planets that are revolving around the sun, and they're flying through space, basically on a kind of plate, on a saucer that's flying at a slight tilt like that. And round about our solar system, as it flies through space, is a thing called the Oort cloud, which is made up of dust and ice. And it's 10 to the power 5 times the distance between us and the sun to this cloud. And it's a cloud of ice and dust. And even bigger than this sphere, here's the sun in the middle, and here's the cloud of ice around it. Even bigger than this, we've apparently got little clusters of brown dwarfs, suns that have kind of burnt out all of their hydrogen and have only heavy helium cores left. And they're travelling a sphere that is 300,000 light years above the ecliptic, i.e. above the saucer that we're flying through. These old brown dwarfs, they fly up and they fly down in a huge cycle, hundreds of thousands of light years. They too are making a sphere. And so the ancients had this idea that before anything moved at all, there was a thing called the monad. This is Leibniz's word again. Remember, the man that came up with the maths for the hologram. He said originally there was just one thing. You couldn't tell the difference between, for any place in it looked the same. You could get from anywhere in it to anywhere else. Basically, it was an infinite sphere whose border was nowhere and whose centre was everywhere. Now, the words we'd use nowadays, and in a company like this I have no fear of using these words, is isomorphic and homogeneous. Isomorphic means it looks the same in whichever direction you look, and homogeneous means wherever you are in it, it looks the same. Now that is exactly the description that the physicists currently have of our expanding universe. So that shows that people were working on the ideas that we're exploring now hundreds and hundreds of years ago, and what we're dealing with here is a continuation of those ideas. It's just that we've got some flash maths to explain it all. 17th century, I think he was, yeah. Let me just make sure that I'm, oh, well done. So that's the sphere then, this idea of an infinite thing before there is anything else, and that is unity. The monad, it's called the unity, the foundation, the seed. Again, we all read about it again and again in myth and in our researches. It comes from the Greek, which means to be stable and oneness. It's in the language of our culture, it is the face of the deep before spirit moved upon it in Genesis. The primal matter before anything has differentiated itself. And the starting point, the monad, is all there was and is. It's the container of absolutely everything. And what we do is we imagine for the starting point of geometry that the monad moves itself down to a single dot. And at this point, I would have a picture of a single dot on the screen, but I'm sure you're all going to have no problem imagining that. Now, we know there's an above and a below. We know there's an inside and an outside because we're third-dimensional entities, but for the purposes of geometry, we call this naught-dimensional. We imagine that it's absolutely everything down at this single dot. And we know, coincidentally, don't we, that that's where physics has got to. Sometime in the dim and distant past, 15,000 million years ago, there was an infinitely small thing that also was infinitely massive in the proper sense of the word. It was infinitely small, but it contained all the mass that's currently in the universe, and it went bang. So once again, in geometry, we're looking at something that's in physics. You start to see how these very simple ideas are becoming extremely relevant.